Hey, this is Miss Prater, your Algebra 2 teacher, and I am going to video the 6.14 Unit 6 review. So I'm going to go straight to number 1. It says the probability of distribution. The probability distribution shows the probability of owning multiple vehicles among 100 families polled. What is the probability that a family has more than 3 cars among the 100 families that were polled? So more than 3 out of 1, 2, 3, 4, and 5. More than 3 would be 4 and 5. Both of those are measuring 0.05. So that would be adding those up. And that would give us a probability of 0.10. Nice little chart. All the probabilities have been done for you. Definitely could have been harder. Number 2, use the probability distribution table to answer the following questions. What's the probability of x being greater than or equal to 2? Greater than or equal to 2 would be 2, 3, 4, 5, and 6. So we're going to add those all up. So these right here. And that's going to give us 0.88. So the probability of whatever x is, it could be whatever, we don't know, that didn't tell us in this problem. The probability that x is going to happen when x is greater than or equal to 2 is going to be 0.88, and it does say use a decimal. Number 3, what is the probability for p of 1 as a decimal? It says the frequency table was made. Okay, this is a frequency table. So if you're not careful here, you're going to forget that these are frequencies. So we have to add all these up to get our total. So I think our total adds up to be 200. Let me double check that. So 30 people, that didn't give us a lot of information, but 30 people had 1, 44 people had 2, 12 people had 3, 28 people had 4, and so on. So we got to find out the total here before we do a probability. I'm just double checking the 200. Yep, 200. So it says use the frequency table. Oh, these are spinner numbers from the spinner sections that are numbered 1 through 6. And then it says what's the probability of getting a 1 on the spinner. So that's going to be 30 out of 200, and it says decimal. So I'm going to do 30 divided by 200. Always do top divided by bottom. And that's going to give me a probability of 0.15. So don't let this one trip you up. It is a frequency table. You've got to figure out the total and then go with how many spun a 1 over the total, and then divide top by bottom to get your decimal. Number 4, Tina has 2 spinners. One spinner has 4 equal sections. I'll underline that. And they are 1 through 4. The other spinner has 5 equal sections, and they are 1 through 5. Trina spins both spinners at the same time. The random variable x is the sum of the numbers on which the spinners land. What is the probability that the sum will be between 5 and 8? Okay, so this is what I would do. I would make a tree diagram. So on my first spinner, I could get a 1, a 2, a 3, a 4, or that's it. 1 through 4 on my first spinner. It's right there. My second spinner has 5 equal sections, and they're 1 through 5. So then this one's going to have 5 branches. Now I'm not going to do the tree diagram all the way down, but I'm going to write the possibility. So I could get a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5. And then I could get a 2 and a 1, a 2 and a 2, a 2, a 3, a 2 and a 4, a 2 and a 5. Or I could get a 3 and a 1, a 3 and a 2, a 3, a 3, a 3, a 4, a 3, and a 5. Or I could get a 4 and a 1, a 4 and a 2, a 4 and a 3, a 4 and a 4, or a 4 and a 5. And we're talking about adding these numbers. So if we add and we get 5, anything 5 to 8, so we could add and get 5. and anything in between. So anything that adds up to be 5, 6, 7, or 8. So 1 and 1, that's 2, that's 3. I'm adding 4, 5, that would work. This would be 6, this would be 3, this would be 4, this would be 5, that would work. That'd be 6, that would work. That'd be 7, that would work. This would be 4, this would be 5, that would work. 6, I'm adding 7, 8, this would be 5, that would work. This would be 6, this would be 7, this would be 8, and this would be 9. So that would not work. So I've checked off 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Out of, if I count all these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 13 out of 20, that doesn't reduce. So I would choose the fraction 13 out of 20. Number 5, a veterinarian is using a new vaccine for cats. The vaccine has a 10% probability of causing side effects. Everything causes side effects these days. In which distributions does X have a binomial distribution? Select each that occurs. So let me talk about this. In a binomial distribution, you have to look at the problem and say, okay, this is going to be a success and this is going to be a failure. You can't have a third choice. So the problem has to be set up as a success and a failure. There has to be a set number of trials. So they can't just say, hey, we're going to test some cats. They have to say, we're going to test 5 cats. We're going to test 2 cats. And then the third one, each time they test, the probability has to be consistent. So if the success is 2 nights, then every single time you test, the success has to be 2 nights, and the failure has to be 7 nights. So the probability has to be independent. It's got to be consistent. It says when the vaccine is given to 6 cats, that means 6 trials, that's set. X is the number of cats that do not have the side effects. So that means some do not, some do. That would be binomial distribution. The next one says when the vaccine is given to 3 cats, the trials are set. X is the number of cats that have the side. So success would be have it, failure would be not. That would be binomial distribution. When the vaccine is given to multiple cats, that's an automatic no. Doesn't tell you how many trials you have. And the last one, when the vaccine is given to multiple cats, again, we can just throw that one out. It has to tell you the number of trials. In this case, it would be the number of cats that we're trying the vaccine on. Number 6, use the probability distribution graph to find out the questions where X is greater than or equal to A, which is 0.5. Okay, I think this one's a little bit confusing. So what we're going to do is, if they're saying X, okay, we're looking for the area under this graph, which would show probability that is 0.5. So what I would have to explain first is I'm going to take one little square and talk to you about the square for a second, because we're going to count up squares, and which each square represents area if it's shaded in blue. So this side here is 1 unit, because I'm getting 1 right there. This going up is 0.5, because that's 0.5. So when I do 1 unit, 1 area, that's going to be base times the height. So that's going to be 1 times 0.5. So that's going to be 0.5. So what is the value of A? So on this one, I got, and let me read this again. It's X is greater than or equal to A. So that means the area would have to be greater than or equal to 0.5. So would that happen? Would it happen where we're greater than or equal to 1, greater than or equal to 2, greater than or equal to 3, greater than or equal to 4? So what I would do is I would look at A being 1. Okay, so at 1, let's just kind of make a chart here. I don't have a complete square here. So at 1, my area under this shape is less than 0.5. So I'm just going to say 0.4. So I can't include the 1. So it says we want the area to be greater than or equal to 0.5. So if I go to 2 and I count, I'm going to have these boxes. And we said each one of these areas is, and by the way, I did this wrong. It's not 0.5, it's 0.05. So this is 0.05. So this would not even be 0.05. It would be like 0.04. So if we counted these up, that's 4 whole boxes. So that would be 0.05 times 4. That would just give me 0.2. So, and even with these partials, I'm not going to get something greater than 0.5. So now I'm going to go to 3. And if I count these up, that's 1, 2, 3, 4, 5, 6, 7, 8. Now that's 8 of these. Those are 8 wholes. That's going to give me 0.4. And I have these 3 partials. That's going to make it go to 0.5. So 2 is still less than 0.5. But when I get to 3, I have 0.4, and then I have these partials, which is going to get me to 0.5. So they want 0.5 or higher, 0.5 or higher. So that's going to happen when A is 3. Got to get all the way to the 3 for that to happen. So again, I would take one of these squares and figure out what the area is. So it's 1 by 0.05. So if I do base times the height there, that's going to give me an area of 0.05. We're trying to figure out where is the area greater than or equal to 0.5, not 0.05. So you got to add up the squares and figure out where the area is 0.5 or higher, and that's going to start with 3. I think this may be the hardest one on the review. Number 7, the masses of oranges on sale at a farm stand are normally distributed with a mean of 239 and a standard deviation of 25. Enter the z-score of oranges with a mass of 259. So we're going to use our formula for z-score. It's raw score minus mean divided by standard deviation. So here's our raw score of 259 minus our mean of 239 divided by the standard deviation of 25. So 259 minus 239 is 20. 20 divided by 25 is 0.8. So the z-score that they're looking for is 0.8. So here's your mean, here's your standard deviation, here's your raw score. Number 8, the heights of the children in a summer camp are normally distributed with a mean of 54, a standard deviation of 2.4. What is the height of a child with a z-score? So this time we know the z-score is 1.5. So we're looking for the raw score. We're looking for the raw score here. So we're going to use the same formula, except we're going to be looking for x. It does say enter your answer round to the nearest tenth. So we're going to use the formula. Z is equal to raw score minus average divided by standard deviation. This time we know the z-score, so we're going to put in a 1.5 for the z. We don't know the raw score. That's what we're looking for. Minus the average, 54, divided by the standard deviation, 2.4. I would set up a nice little proportion here. I would cross multiply and get x minus 54 equals 1.5 times 2.4. That'd give me 3.6. I'd add 54 to both sides, and that would give me a raw score of 57.6. And that's what I got when I worked it last semester. Checking my notes. All right, this is a review for Algebra 2, Unit 6. Unit 6 review. Hopefully this was helpful. If you need anything, don't hesitate to reach out.